Hey guys, it's time for some more geometry. Today, we're going to still continue being exploring classifying shapes via their attributes. And remember, an attribute is something that we can use to describe a shape for what it is. So for example, a circle has no corners, no edges, is fully round, and is not a polygon. Those characteristics are true for that circle and not for a square. So how can we classify all of these different shapes? To review, we have sides, angles, which are the inside, and the vertex, which is our corner. So that's going to be the outside point. And I remember that because it's often in the shape of a V. So our sides are our edges, angles are measured on the inside, and then vertex or vertices are going to be those points at the ends. We're going to look specifically today at polygons and quadrilaterals. And a quadrilateral is a shape that's going to have it's going to have only 4 sides, 4 angles, and 4 vertices. When we look back at our resource page, we can see that we have a ton of resources on quadrilaterals. So there is a BrainPop Junior video specifically on quadrilaterals to help you review, to see how many you can come up with, how many you can name. There is a YouTube video that is a funny song on quadrilaterals to the tune of Radioactive. So this is always a fun one that we enjoy watching. And then if you go back over here, there is just a single page that has been linked. There are dozens and dozens of resources out there for specific quadrilateral worksheets. In some of those other links that I posted for the basic math worksheets for kids polygons, there are going to be some sections in there that you can search for that reference quadrilateral shapes. So if you're looking for something specific on that, there are going to be some more posted for you. And then as well as this Nearpod code, if you haven't gone to that Nearpod and entered that in, that's a great way to make sure you're ready for today. So one of the things that makes quadrilaterals so unique is that there are so many of them. So when we're filling out those charts that say how many sides, vertices, and angles do they have, we notice triangles have 3, but then we get to squares and parallelograms and rectangles and rhombus and kites, and all of a sudden we're like, wait a minute, there's a lot that have 4. Pentagon has 5, hexagon has 6, and they look pretty much the same throughout unless you're talking about irregular shapes. So all of these shapes can be classified into the overall bracket of quadrilateral. And then we have different brackets where we talk about trapezoids. A trapezoid has these angled sides that if we continue to go up, it would make a triangle, which is how I help remind myself about the tra in the beginning of trapezoid, is that if I continued that, it would make a triangle shape. And then an isosceles trapezoid, which is just going to be a different trapezoid figure that we're not really going to focus on too heavily in 2nd grade. You can also see that a kite is separate from this next category. A kite is, a few of you noticed, is similar to a diamond shape. But with a kite, our top 2 pieces are going to be much smaller, or we're going to notice that their angle is much different than the bottom one down here. We can see that this is a very narrow angle and this is a much wider angle. So that's how a kite is going to be different from a diamond or a rhombus shape. Parallelogram is another category, and what that's going to talk about are parallel sides. When we look at 2 L's going up and down together, if we were to continue those going on and on forever and ever and ever, they would never cross. They would just keep going, keep going, keep going. So if I look at this line here and this line here, they're going to keep extending on and on and on and never intersect. This line right here and this line right here, same thing. If I were able to continue those on, they would not intersect. Now, if I look at this kite, if I were to take this line and this line, they're already crossing right at this point. So that is not a parallelogram, which is why it's in its own bracket. Same with a trapezoid. It has one set right here that if I continued these going on and on and on, they would be parallel, they would not cross. However, if I take this one and this one, so we're always looking at the ones that are on the opposite sides, they're going to keep going and they're going to eventually cross and intersect. So that's why they're in their own categories. From parallelograms, we can see that we can have a rectangle, we can have a rhombus. Rectangle is going to have 4 right corners, and that's going to be that perfect L corner. Then we can look that it connects to a square. A square can actually be a rectangle, but a rectangle isn't always a square. What do you think I mean by that? Well, in order to be a square, you have to have all four sides equal, whereas in a rectangle, you just have to have two sets of parallel sides and four right angles. So there's a lot of resources here to help you focus on the classifying the specific quadrilaterals. We would typically spend a couple of days just reviewing and rehearsing, kind of exploring and having math talks and discussions. So I'll pose a couple of questions on Seesaw to get your wheels spinning and some thinking about how to classify some of these different parallelograms and different quadrilaterals. The main thing you need to remind yourself is when you're tasked with a question about, is a shape a quadrilateral, what is true for all quadrilaterals? All quadrilaterals have to have four sides, four angles, and four corners. What those sides and what those angles look like are going to be different, and that's how we classify those different ones. But they all fit under that bracket of quadrilateral if they have four sides, four angles, and four vertices. So for today's activity, typically in class what we would do is we would have, and I'll post a Seesaw activity that, is it a quadrilateral or is it not? But you want to be able to verbalize, is a triangle a quadrilateral? Why or why not? Is a square quadrilateral? Why or why not? So today's activity has you thinking creatively about why a square might not want to be a quadrilateral. Why does it want to be a circle instead? So think of some attributes that maybe a square would want to have that a circle possesses that the square does not. So if we look at today's activity, we can go in and see that it is lesson D. And I believe they accidentally marked it as lesson C here, but it does give you a cute little template if you wanted to use that. If you don't, that's okay. But one of the things that I'm really encouraging you to think about is, what attributes does a circle have? For example, does it have corners? Does it not have corners? Does it have angles? Does it have things that would prevent it from doing certain things? Why would a square want to be a circle? Think about how they could be different and why they are different and why we classify them differently. And then maybe you could write it from the side of the circle. Why would a circle want to be a square? Or if you want to take this to another level and you want to talk about different shapes, you can go ahead and do that as well. It's just going to be a fun way to get you thinking about the attributes of quadrilaterals, attributes of squares versus circles and things like that, getting you to think about them in a different way. As I said, I will put a template on Seesaw that will just be quadrilateral versus non-quadrilateral, so you can review that today. And then if there's anything else I can think of that would be beneficial for us to practice today, I will share with you. Or if you have anything that you want to share with me, just take a picture, send it in, and let us know how you do.